Students led me to it. I have been creating online tutorials and online learning modules to teach how to perform engineering simulations for a number of years now. And when I've asked students what has been most useful for your learning, the online tutorials and the online learning modules have consistently ranked the highest. And my lectures have consistently ranked the lowest. And this surprised me because I was putting most of my effort into the lectures. And then I also realized that sometimes I used to make mistakes in these online modules, and I would tell them in class, hey, by the way, I made a mistake there, and you should do it this way. And almost all of them, when they were doing it in the homework, they would do it the way it was in the online tutorial. So it was like, okay, I realized that students, whatever was online, they treated it as gospel. And I felt like, okay, now this is the way I really need to convey the information to them, rather than through face-to-face, time, which I felt like I should be using more to mentor them in problem solving and so on. So it was really students who led me to it. After recording about 200 videos in that self-recording setup, I think that's the way to do the online lectures. I had a tablet, and the tablet was the blackboard. And whatever was projected on the monitor also appeared on the tablet. So that, if, for instance, if I had the PowerPoint on, it also showed up on the tablet and I could write on the PowerPoint. Which meant that, usually you have the blackboard and the PowerPoint. And you go between one and the other. And, I've been in conversation with colleagues where, talking about, oh, I won't use PowerPoint, I'll use only Blackboard and so on. And in this way, it's not an option between one or the other because they're overlaid. And not only that, in my case, I'm also teaching them how to use the software tool, which is extremely important in engineering. So the software tool, if I'm launching the software tool, which is called Answers, it also shows up on the tablet. And so I was very pleasantly surprised that I could also annotate over the software. So I could say, hey, the software is hiding the equation from you. And here's the equation, and I could write the equation and say, okay, we talked about this before. So that way I could also bring out things that the software was hiding because it's, after all, a mechanism to solve the equations that we wanted to solve. So I felt like the self-recording studio allowed me to overlap the Blackboard, the PowerPoint, and the software tool, and very effective, I thought. So typically each video was maybe 5 minutes long. I would pick a concept and I would kind of, describe it. I would talk about it. Most of the videos, I started off full screen and I would say something like, oh, we looked at how you convert these differential equations to algebraic equations. And then I'll go back to the equations, and at that point, from being full screen, I become small and the focus changes to what I'm writing on. But I'm still there, so I can still make eye contact with the students and so on. And then at the end of the segment, I would say, okay, I would come back full screen, and I would say, by the way, so I showed you how the software kind of treats these equations, but in the process, an error is introduced. And next, we need to take a look at how you minimize these errors. It becomes a very efficient way to do things. I've thought, the self-recording studio, I should have it in my own, in my own office because it's a relatively low-cost thing to set up. So I would need, instead of having the standard webcam, I would need like a higher quality camera. I would need a higher quality microphone. I would need some better lighting and maybe a reasonably good background. That's all I would need. I can shut my door, I can sit down, and I can record my lectures, and I can reach students all over the world. And I can also have, it'll also be useful for Cornell students because they have the lectures now, and my role becomes, not lecturing, but mentoring them. It was indeed a big time investment, but I think of it as, a big upfront investment that'll pay off in relatively short time. Previously, I was repeating these lectures over and over again, but now it's all recorded. So I don't have to repeat these lectures. And also, when I'm talking to students, I would say, oh, by the way, I talked about this in the lecture. Do you remember it? And of course, they don't. But I can tell them, you know what? You need to go and watch this video. I talk about how I linearize the equations in this video and what the errors are coming out of it. So I feel like it's, it saves me time in the long run, but it's also more effective in mentoring students and helping them with the problem solving because I don't have to repeat this content over and over again. In engineering, what happens is, you take a practical problem like a bolted joint, which is one of the practical examples I present in the course, and you want to know what is the margin of safety of your joint, or what is the gap that opens up so that you don't want to have gas escaping from that joint. You can construct a mathematical model to it based on the physics and the math, and you get a mathematical model that is very complex, and you cannot solve it without the software tool. And that's what you do in engineering. Right? You have these problems and you use a software tool to solve these mathematical models. Now, if I bring it into the course, I can solve these complex mathematical models using the tool. Usually we avoid these complex mathematical models because it's like, we can't solve it. So what's the point in talking to, telling students about it? So I was able to bring in these complex mathematical models. The other advantage of using simulation software is that you can visualize the results. And that's a great way to kind of build intuition, understand what's going on, because the software, you can make apparent things such as fluid flow, which you cannot see, or, so you can bring out like what is the physical principles, that are embedded in the equations or in the solution and so on. So that way also it's a very effective teaching tool. And it's also a practical skill that, employers are really looking for, and universities are struggling to teach because you cannot integrate the simulation tool into a conventional kind of classroom. Whereas online learning, it's natural. You're already at the computer, launch the tool, and solve your mathematical model, and look at your practical application. You have to go online to bring in simulations. In the conventional lecture, right, you have the Blackboard, you have the PowerPoint, and then even if you're showing, if you know the software and you're showing students the steps and so on, it's not very engaging, first of all, to see somebody using the software. And by going online, not only, students are not only watching you, but they are following. So naturally, when you go online, it becomes a hands-on experience that the students are seeing, okay, this is what you need to do to solve this heat conduction problem or this bolted joint problem. And so they're following along, and naturally becomes hands-on. And you without going online, you really cannot bring simulation into the teaching. There are two differences, I think. One is that in a regular classroom, it's usually like a 15-minute lecture, and I have the Blackboard, the PowerPoint, and the software tool all like being, kind of separate entities. Whereas now, the way students engage with the material is I have these short video segments. Each lecture segment was about 5 minutes long. And if I was using the simulation tool, they're also following along. And then after they watch that, I have like a little exercise that they need to do so that you're watching, you're understanding this concept, and then you have to apply it. And you get immediate feedback, whether you got it right or not, because it's like a quiz and so on. So that way, the students, the way they engage with the material and with the lectures was different. The second is how they got help. Usually, you would come to office hours if you want help, and you would get it from the TAs and so on. Though now, more and more, we use discussion boards and so on. So even in Cornell courses, a lot of the help is being delivered online. Whereas here, the help was all delivered online. So it was, I had a few TAs who were kind of monitoring the discussion boards and looking at the, what were the major issues that came up and so on. And if there were some major issues, instead of office hours, I create office hour videos so that I could, respond to students if there was some major confusion or misconceptions happening. Interestingly, there was a lot of peer-to-peer learning happening in the online version, which is less apparent in an on-campus course. The major difference was how students engaged with the lectures and how they got help. I was drawing actually content from 5 courses. So you can't really compare it to any conventional kind of course because this is a new kind of course. I think of it as like flipping the curriculum because I was exposing what I deem as like freshman level or sophomore level content. I was exposing, students at that level to content that would be considered kind of advanced. But again, that's, the advantage of bringing in the simulation tool. I've got to flip the classroom. If it's online, then why repeat the lectures? And anyway, students prefer the online lectures. So the idea is to have students go through, engage with the content before and complete a quiz. And then when they come into class, they have already engaged with the content and have them do the homework so that they're applying the concepts, and that's when they need the most help. And I've tried some experiments with this already. Because I've been doing, these online modules and so on. So in a conventional lecture, right, you describe some complicated thing and you ask any questions, it's like there'd be no hands. Or there'll be like the same one or two people. And especially in big classes, because students don't want to speak up, in front of like a big audience and so on, it can be pretty challenging. Whereas once I flipped it, I had the students go through the online module and they were working on the homework, and they were like hands going up all over the place. And I felt like, okay, now I was going into the students and helping them, in smaller groups and so on. So that's what I hope to, how it'll change my face-to-face teaching is that I will have them go through the online content before they come to class and then do the homework in class. It doesn't involve any more effort for the students. It's just how their effort is distributed. They get the help when they need it the most. And for me, I think it'll actually, decrease my effort because I don't have to repeat the lectures, and I'm spending my time helping students, which is, I think, it's much more interesting for me and it's much more valuable for the student. I was surprised how effective online lectures can be. So now, if I'm given a choice between doing a conventional lecture and doing an online lecture, I would, prefer to do the online lecture and use the face-to-face time helping students kind of apply that knowledge, mentoring them. So that way, I think it helps me move from lecturing to mentoring, which is, I think, much more valuable for students. One of the modules was, again, the bolted joint one. It's one of the most common problems you encounter in engineering analysis, and conventionally we don't teach them. So what I did was I worked with an expert at SpaceX, which is, students really look up to that company because it's really pushing the boundaries of space technology. And I worked with him to create this example of how do you analyze this bolted joint. And then, I was basically doing Skype with him. He's on the other, on the other coast. And he was showing me things, he showed me how you take this bolted joint from a rocket and how do you create a model. And that's knowledge that I don't have. But he does it in his own work, designing real nozzles and real rockets. And also he, in terms of interpreting results and so on. And I was like, okay, students really need to know how you take a complicated, problem and reduce it to something you can analyze and be useful. And they need to hear directly from you. So I just did a Skype conversation, and he described his thinking process. I looked at this application and blah, blah, blah. He described that entire thinking process. This is something that we never really teach students, but it's become extremely important in engineering. The other thing was when you get results from the software, and you have to really know how to interpret the results. And again, I was having these Skype conversations with him to understand myself, and he was like, talking about these NASA specifications and so on, which I have no clue about. And I said, again, students need to hear from you. So what I did was I had him bring up his results. So students have their results. And then they have this video of him bringing up the results and me asking him, okay, you're looking at how, the joint is deformed. What are you looking for? And he describes, what he's looking for. And again, by going online, you can really bring in this industry expertise right within the context of how, when students are learning and solving the problem. And students really, really appreciated that. nothing radically different. There was a learning process, but in the end, all the elements kind of came along, and I think I'm going to not do anything radically different. There's some fine tuning to do, but I think I now have the process to create online courses.